Alright, now we're going to use these parent functions to identify all critical values that would show up based on how their graph looks. So first up, we're going to look and identify the parent function, either the equation or the name of it, doesn't matter to me. We see the absolute value marks. So normally it's just this absolute value of regular x, and the shape of that is what's really important. Okay, we're looking for the V shape, and based on that, we're going to have some special critical points. Every single one is going to look for the x and y intercepts. There's only one y-intercept for all functions, but sometimes x-intercepts have more than one. If we're looking at our graph here, our x-intercepts may have two, kind of like a parabola, depending on where this has gone. Y-intercept, it's going to cross once somewhere. So the math for this comes from exactly what these are on the graph itself. A y-intercept is on the y-axis, so it has to be 0 something. That's what we do to find the y-intercept, is we plug 0 in right for x where we see it. For us, that looks like 0 plus 25 is 25. The absolute value of 25 is still 25, and then you just subtract 10, y-intercept is 15. So it wasn't just this thing on the end like we saw with some of our other parent functions. X-intercepts will do something similar. We're putting a 0 in for y this time, and we're going with our original equation. 0 equals absolute value of x plus 25, and then the minus 10 on the end. To solve this, we're going back to how we solved equations from the get-go. We want to solve for x, so we want to get x by itself. Okay, first thing here is we're going to add the 10 over to the other side, and we're going to think for a minute. This says when you take the absolute value of x plus 25, you get 10. First thing, double check if this number is even possible. What I mean by that is when we take an absolute value of something, this number must be positive or 0. And because it's 10, we're good to go. But if this was ever a negative number, that would just mean we didn't have x-intercepts. Sometimes your v can be translated so it's floating in the air. Sorry, my pen acted funny there. But it could look something like this if you ever had a negative there. Alright, this time we didn't, so we're going to go solve for the x-intercepts that we actually have. There are two. In this case, here's how it works. We are saying that this number has to equal 10 because we know that the absolute value of 10 is 10. So let's set that up. X plus 25 equals 10. Moving that over, x equals a negative 15. Okay, if you plug in negative 15, we get that 10. We're good to go. That's our first one. All right, but the shape told us that there's supposed to be probably two of them after a transformation, and that's because we could also say the absolute value of negative 10 is still 10. So the second part of this is we're going to set x plus 25 equal to a negative 10. So x equals a negative 35 there. And those are our two x-intercepts. The last thing comes from the thing that was important on the graph that I had you label, either a point or asymptotes. So here, we were at 0, 0, and what we're going to do to find out what happened is look at whatever's in your grouping symbols of your parent function. So our grouping symbols were those absolute value marks. We see x plus 25. If you take that x plus 25, or whatever you see inside, and set it equal to 0, you find that important point, which for us, you can call a vertex, but it's also just the minimum. And so x value of that minimum is negative 25. Okay, and then you plug that negative 25 in the original. Negative 25 plus 25 is 0. Minus 10 just gives you negative 10. This right here explains all of the things that you were learning in Algebra 2 about transformations of graphs. Remember when you saw plus 25, that meant your graph moved to the left 25? That's just because how we solve for x. Then, when you plug it back in, that whole thing should go to 0 by default, and so you're only left with what's on the side. That negative 10 meant down 10, and that's precisely what happened with our point. So final answer, all of our critical values found right there. What I want you to do after you find those is just double check yourself with your graph. They'll show up. You can find them just the way we normally did. Okay, I'm going to be looking for your work to show that you did this algebraically. Next one, again, first is just identify the parent function. Ours here is the square root. And you're always going to look for y-intercept, x-intercept, or more. And then anything else that may be important, minimum, maximum, asymptotes. So looking at our picture, square root function starts at 0, 0 and goes up from there. There are no asymptotes, but we do have a minimum value, or this is also known as the end point. And we're going to find where that moved to. So y-intercept, 0 comes first, and that's how you find it. We're going to take our equation and we're going to plug in 0. 0 minus 8 inside plus 5 outside. Here we get a negative 8, and we just found out there's not a y-intercept because we cannot take the square root of negative 8. That causes problems. It can be done, but not with real numbers. That just tells me, and you can look at your equation, figure that out, when we were looking at this square root function, normally starting at 0, 0, remember this minus 8 means to the right 8. So no longer cross that y-axis. There are none. X-intercept, we're going to do the same process that we did on the last one. We're going to put a 0 in there and see what happens. So 0 equals, for the y value, square root of x minus 8 plus 5 on the outside. Just like last time, we're going to get that x by itself. Subtracting 5 over, and then we pause. Just like on the last one with the absolute value, this thing's a square root. When we take the square root of a number, we're going to get a positive number. We're not talking about solving equations. We didn't create this square root by trying to solve. It was already there. Because it's already there, and if you think about this shape here, remember the whole idea of this square root is it ended up being positive. This will not work. There are no x-intercepts. How you can kind of look out for yourself on these weird graphs is starting with the endpoint. That'll tell you where your graph is to kind of help you with knowing whether x-intercepts or y-intercepts should happen. Remember, all you have to do to find the special point is set whatever is in the grouping symbols equal to 0. So I know the x value of my endpoint is 8. It went 8 to the right. Similarly, this plus 5 gives me a transformation. We ended up going up 5. The math for that is just plug it in. We get 0. 0 plus 5 is 5. Because that endpoint ends up being over here, and we know the shape of the graph, that tells you there are no x-intercepts, no y-intercepts for this transformation. Okay. Last one, we've got 1 over x minus 5. The parent function for this is y equals 1 over x. It's called a hyperbola, and the sketch of it matters because that's the whole idea of what we're looking for over here. With the regular hyperbola, there are not y-intercepts or x-intercepts because of the asymptote showing up. I want, when you're sketching the parent function for anything with asymptotes, for you to label them because they're important to answering the questions over here. Just like when the last one had an endpoint and a minimum, these asymptotes are going to be something that we identify. So what I want you to do is write vertical asymptote, and horizontal asymptote abbreviated. Those are things we're going to find with this particular graph. Alright, process stays the same. First job is finding the y-intercept if there is one, and you're starting with just plugging in 0. So going to your original equation, 0 minus 5 is negative 5. You're left with 1 over negative 5. Y-intercept should never take long. X-intercept, we're going to take, and instead of the y value, we're going to write 0 equals 1 over x minus 5, and we're going to solve this equation. Now, anytime you see x in the denominator, your very first step will always be to get this whole thing out of the denominator. So the process for that is just multiplying over that denominator. You want to put grouping symbols there, and then we're going to multiply by that whole quantity on both sides. So this says 0 times something, which we know is 0. The x minus 5's cancel, we're left with 1. Because that's not true, there are no x-intercepts. And because there are no x-intercepts, essentially what that's telling you is this y equals 0 stayed. Here's another thing that tells you that. With transformations, whatever is with x is going to tell you a transformation left or right, and whatever you see to the side will tell you if there's a shift up or down. We don't see anything to the right, so there's no shift up or down. We can go here and fill out our horizontal asymptote is y equals 0. To find the vertical asymptote, that's that denominator that we've been talking about with those special values. All you have to do is set your x minus 5 equal to 0. And that means x equals 5. That's literally where your x equals 0 has gone to. Remember, if you see a minus 5 with x, it goes to the right 5. And so our new asymptote is there instead. You can check yourself on this one as well. And what you would want to be careful on anytime you're typing in something with the parent function of the 1 over x or the 1 over x squared is when you see two terms, they must be in parentheses. So as you type that in to check yourself, make sure those are around that denominator. All right. If you have any questions while you're working on your homework, please feel free to come see me.